Hello, my name is Abhishek Sinha and welcome to this demonstration video. In this video, I am going to demonstrate how to modernize legacy apps with the help of cast imaging MCP server powered by LLMs. So let's get started. In this feature, I am going to guide you through the high stakes world of transforming a complex multi-technology application. For this demonstration, I have zeroed in on a classic example, a legacy JCL batch process for our sample application code. As you can see over here, this sample application has got a lot of components along with multiple technologies, starting from CICS, business logic. You have COBOL, you have DB2 database, you have Java, you have other typical data components. I'll be showing you step by step how we take this batch process and modernize it into a verified cloud native solution, all driven by full stack context and the sheer power of cast imaging MCP server for LLM enabled IDEs. The application, it's a mix of mainframe, DB2, Java code, and the mission is to tackle the critical quarterly data backup process that I'm going to showcase here. And what it does basically, it originally backs up some of the data from the database, and originally it is living in JCL. Our philosophy here is very simple. We'll demonstrate the evidence-based modernization, and the foundation for all this, it's a cast imaging application analysis. This engine scans all the languages involved like JCL, COBOL, Java, and DB2, and stitches them together into a fully navigable relationship-rich graph. Let's jump into the application map and pinpoint our target process. So like you can see, the backup job starts from here, then it moves to this procedure, that backup proc, which has got two different components that further takes this particular job into existence and how it exactly does the overall execution. Using cast imaging, you can quickly investigate and trace the entire call graph. Not only that, you can immediately look into how things are connected to each other. Like this particular process is further talking to another components like these two, as you can see, and then it looks into the data set and its entire network of downstream jobs as well. Cast imaging has a capability to run through each and every line of your source code, giving you the complete application architecture, getting into your third-party components, and showcasing you the vulnerabilities, the aging gap, and where all it is impacting. It also has a capability to go and start getting into individual database components. So how you can see over here that how the DB2 process, the functions, and other tables are talking to various components of this application. Not only that, cast imaging has a capability to compare your source code against various blockers and boosters which are recommended by the cloud platform providers. Now here in this case, you can see that how efficiently you can identify those impediments that you need to remediate before your application needs to be moved onto the cloud. Not only that, let's say you want to move your database from an old legacy database to a newer one, maybe in this case from DB2 database to PostgreSQL, or let's say you want to move from DB2 database to MySQL. You would want to know that what are the things that you need to remediate. Like in some cases there could be syntactical remediation that you may want to perform, or in other cases you may want to look at the the code based remediation, that where exactly things needs to be identified and fixed. So all those things cast is able to identify and quickly give you an insight and what needs to be done. So like here you can see from DB2 database to PostgreSQL with syntactical remediation and even the data type based remediation. So now that we have already scanned our application source code in cast imaging, we are good to go and take this mammoth knowledge base onto our AI based IDEs. In this case, I'm using Tray, an agent using cast imaging MCP server, and now I'm good to go. The key to successful modernization starts right here on the developers and architects desktop. It is achieved through the seamless integration of cast imaging MCP with your IDE. This information is non-negotiable for successfully modernizing any legacy application. This rich contextual map is what truly empowers your team. It enables architects, developers, and even LLM tools to trace every transactions and dataset, efficiently delivering accurate business rules that can be validated by your SMEs. Now that we are armed with CAST's verified knowledge base, developers and architects can leverage these AI-based IDEs to generate a modernization plan packed with context and meaning, like I have been able to do in this case. With the help of CAST imaging, MCP servers, contextual information, not only I have been able to enrich my prompt, I have been able to give more information with lesser tokens that enable me to generate more meaningful information. It enables me to create a as is architecture documentation, further enriching it with the proposed microservice based decomposition plan, enabling me to identify those proposed services, data migration strategy, technology stack recommendation. Not only that, it gives me a modernization roadmap as well. Now all these things can be further elaborated, like I've been able to do. I've been able to identify the database migration plan. I've been able to identify the source table, the target table, the schema that I need to map, and how I need to make changes in the schema, in their syntax, in their data types, etc., etc. So this gives me an action plan. Not only that, it also enables me to begin with something. Of course, I cannot be 100% sure, and I cannot give you that guarantee that we can achieve to 100% accuracy. But even if it is, let's say, 60 to 70% accurate, with more contextual information in terms of your data types, in terms of your data objects, the components that have been used, the technology that have been used in your application, leaving very less scope for LLM hallucinating, and we saving significantly on tokens, leading to more meaningful output and substantial cost saving. So in this case, using a pinpointed prompt fueled by context from CAST MCP through ID, I was able to generate these powerful artifacts like the modernization roadmap, the database migration plan, and not only that, I've been able to identify the business requirement documents for this particular procedure. So now let's take a scenario that you want to understand the business requirement for any particular component in your application. In this case, I have taken a JCL process and I have used CAST imaging's contextual information and fed it to LLM, giving me a complete understanding about the business requirement that I can extract from this procedure, JCL procedure. So I've been able to identify the overall purpose of this JCL. I've been able to understand the as is process analysis, what exactly it does. So like here in this case, this particular process is extracting data quarterly and then dumping it as a backup. So it is archiving the data. Not only that, I've been able to identify the to be functional requirement in a modernized solution, that how I'm going to further decompose this entire requirement into functional requirement. Now I have been able to decompose them into individual functional requirement. Those functional requirements were further brought down into business requirement, and definitely this requires certain hand holding from the architects as well as from the developers. However, when you are talking about a mammoth source code, when you are looking at multiple artifacts, multiple program files, it becomes super easy for you to quickly give this contextual information to your LLM, and it generates this information. Of course, for some or the other reason, you may have to go back and start prompting your and searching into your code base through LLM using CAST MCP, because it already has lot of contextual information stored as a knowledge base inside its database. So now looking into this, you should be able to understand that how easy it becomes for you to translate this code into business information, business related information, business rules, and functional requirements as well. Now that I have showcased you that how efficiently you can create your BRDs, your database migration plan, your modernization strategy. So now let's use these documents and see how exactly cast imaging MCP server using the cast deep knowledge base can help your team to generate more pinpointed approach for any kind of modernization or migration strategy. In order to demonstrate a small feature, I've just giving this chat window a prompt where I'm telling that, okay, now that you have got a the database migration plan and you already have access to cast imaging application scan results for this particular applications, let's discuss and see what are the areas that we need to refactor or rewrite in order to efficiently modernize this database, which is DB2 to PostgreSQL. So let's see what it does. As you can see, it is now retrieving the context. And this has started checking into the COBOL. It has started getting into those knowledge base and see. Let's see what it generates. I'll just pause this video for a second, and then once it generates everything, I'll come back and show you. As you can see, it has generated a detailed understanding about what it should be able to help us with. It identifies the triggers and the COBOL stored procedures that needs to be that bridge, and it also gives me the detailed understanding about what needs to be implemented, how it needs to be implemented, and now I can just instruct it to create a document for me. And here I have a detailed plan which talks about clear scope and objective aligned with your existing docs. That means the documentation that was earlier generated. It also talks about the SQL procedures like these and how detailed inventory of the DB resident logic is, inventory plan and scripts to find embedded SQL in COBOL, J2E resources, target architecture guidance on which logic to move to PLSQL versus application services. So in a nutshell, if we have to go ahead and start reviewing this documentation that it has generated, it has got under the subheadings, it has got the overall database migration implementation guide that talks about the scopes and objectives. It talks about source of truth and inputs, and then it gets into the individual inventory, what needs to be done, how it needs to be done, so on and so forth. So this is what I was earlier trying to explain, that how easy it becomes or how efficient it becomes for a developer or for an architect to identify these things and verify, maybe cross verify one more time and see if it makes sense to go ahead and make such changes. Similarly, if we go back to our previous use case where I was able to generate these business requirement documentation for this JCL procedure, I was able to identify the functional requirements, the business requirements, the business rule extraction, and not only that, I was able to identify some of the non-functional requirement basis which if I want to generate some code, and which I did, and I want to demonstrate that how efficient it becomes for me to migrate this entire JCL code into a Python one. So this is what I have been able to generate. I have been able to modernize and migrate this entire JCL procedure into a Python code, which with the help of LLM, and of course this requires certain testing, and I've been able to test some of the key features. But in case if you want, you can always go ahead and start generating this business requirement document, the functional requirement documents, the way I did, and then you can start taking input from these documents and start producing your source code, the new refactored or even a completely new source code from these functional requirement. It becomes so easy for you to start developing these new scripts and modernizing your old legacy application. So hope this kind of demonstration helps you to understand and identify the key areas that how cast imaging can help you to unearth the unknowns that are embedded into your old legacy application source code, for which you do not even understand the technology because it is so primitive. Not only that, it has the capability to identify, keep everything into the knowledge base, and then pass on that knowledge base through MCP onto your ID, giving you a complete understanding about what exactly is under that black box. So this is what I wanted to explain. Hope you like this video. Thanks a lot for watching. Now that we have understood that how cast imaging MCP server works with any IDE for your LLMs, I just want to ensure that you also understand that cast imaging MCP server can be fully integrated with your Gemini CLI, like I have integrated here. You can use Gemini CLI, and then you can start using your MCP with these functions. So like I have already configured the MCP server of cast imaging over here, and I have got all these tools to use. Now let's give you an example. I have used the application HRMGMT in scope and identify the database migration plan and help me define some of the key I'm just giving a random statement. So let's see how it works. So the reason why I'm showcasing this is because of the simple fact that there are instances where you may not have direct access to any of the LLM based IDs. So the good news is that Gemini CLI is free. You can implement it on your local machine. You can add MCP server, and from there you can start analyzing. You can start understanding the application. In fact, you can actually give instructions to make changes in your source code like it is doing here. So like you can see here, it's super easy to implement, super easy to start using. You have everything in front of the terminal for you to implement and start coding. Hope last but not the least, you can now integrate Amazon Q with the knowledge base of cast imaging MCP server, and can use Amazon Q for understanding your application more in depth and get the insights that were not available without the contextual information provided by cast MCP server. Hope you like this video. Thanks for watching.